everyone. Today we're going to go over 7-1, graphing and transformations of exponential functions. This is the lesson video that has the we do and you do in there, as well as the example. So this is, again, for people who aren't going to be in class due to testing or because I'm testing, so I can't actually lead you through it during class. So this is something to help you out on your homework. So here we have 7-1. Go ahead and get a pen. So one of the first things, this is probably one of the more heavier notes intensive classes than anything else. Do take a moment, pause the video, go ahead and write this down, and sketch the graph for a growth parent function. As we can see, as we go to the right, it's growing because it's going up. So the parent function is b to the x, with b being greater than 1. It is continuous and increasing. The domain is all real numbers, and that is the case for all exponentials. Your range is 0 to infinity. It does get a parenthesis. You have an asymptote, which is at y equals 0. An asymptote is it's pretty much a very invisible line that you can't see. It's there. We have it there kind of more like as a guideline, especially when we're drawing it. You can get really close, but you can never actually touch it, which is very important to know. So we only have one intercept, and it's going to be a y-intercept at 0, 1. So again, pause the video if you need more time to write it. So here we have a decay function. It is very similar to the growth. The only difference we really have here is one, it is continuous and decreasing. And then that the b value, it's still positive, but it's actually less than 1 in this case. But other than that, the domain, range, asymptote, and intercept is exactly the same. You're not really going to see this invisible line. When we draw, it's invisible dashed line is really what it is. So again, pause the video to give you a chance to write it. And then when you're ready to move on, unpause the video. All right, so next here we have transformations of exponential functions. So our general form with the transformations is ab to the x minus h plus k. So there's a couple things that we get to find out. A tells us our orientation shape. It's also our starting value, usually is what we also will tell you. H is my horizontal translation, does it move left, does it move right? K is my vertical translation, does it move up, does it move down? And y equals k will be the equation of your asymptote for the horizontal one. And then b tells us if it's a growth or decay function based on if it's greater than 1 or between 0 and 1. If you have a negative a value, it flips upside down. And then if the absolute value of a is greater than 1, it is a stretch. If the absolute value of a is less than 1, it is a compression. Again, pause the video as needed so you can go ahead and write this down. And when you're ready to go ahead, unpause the video and you can take a look at the examples that we have. So what we have here is example 1, we have 2x plus 1. For some reason, my video, it stopped sharing. So let's go ahead and go back to that. I'm sorry about that. Don't quite know what happened there. Gotta love being on Zoom when things just turn weird. So here we have y equals 2x plus 1. So they want to know if it's a growth or decay function, and then the transformations, and then the domain range and the asymptote. So a lot of this we can do without even having to graph it. I probably would do the filling out information first, and then I would pull up a table using Desmos to go ahead and get those values. But I wouldn't worry too much on getting a graph first. So looking here, whatever is attached to the exponent is my b value. 2 is greater than 1, so this would be a growth function. My transformations, I don't see an a value, so a is 1. I don't have an h value, so h is 0. and I have +1 for k. So this means when a is 1, there's no change, so there's no transformation. H is 0, so there's no transformation. K is 1 means the graph moves up 1 unit. Your domain is always all real numbers for exponentials unless they give us a real world situation, and then that changes. For your range, we have 2 options. If you have a positive a value, your range is from k to infinity. You have a negative a value, your range is negative infinity to k. So a is +1, so my range is going to be from +1 to infinity because k is equal to 1. My asymptote is at y equals k, so my asymptote is at y equals 1. So one of the things we can go ahead and do here, and I'm not going to have straight lines here, it's kind of designed so that you can go ahead and do what you need. The first thing I would do here is go ahead and graph my asymptote at y equals 1. And it's kind of helps me out when I'm doing a guide on graphing it. Because the other thing is, the calculator won't graph the asymptote for you. You'll have a flat line that you're like, okay, it's flattening out, but it won't show you the dashed line for the asymptote. So what I'm going to head and go do now is we're going to go into Desmos and graph 2 to the x plus 1. So let's go ahead and have it so we're going to do 2 to the x plus 1. If you want, you can do the y equals in the front. It doesn't really change anything, but we can see that it's flattening out. It's not crossing 1, but it's getting really close to it. So the next thing I'm going to do is go ahead and pull up a table. And we want from -2 to 3. And all I would do here is copy this table. 1.25, 1.5, 2, 3, 5, 9. So I'm going to go back to that, and I'm going to fill this out. 1.25. We had 1.5. We had 2, 3, 5, 9. I do know when you're working in ALEKS, they want at least 5 points. And so I would just go ahead and plot these points. So 0 is at 2, negative, it's about half. 1 is at 3, so here. 4, 5, 6, 7, 8, 9. And the nice thing about this is on ALEKS, it will draw the curve for you, so you don't have to worry about how nice it looks. You just have to place the asymptote and then place the points, and it will actually make you have a nice curve, unlike mine, which is very wiggly. But that is exactly what you need to do for the blanking out for graphing it. All right, our we have another one. We have 0.25, 4 to the x minus 6. This one's a bit more obvious in some of the information. So my b value is 4, so it is a growth. My a value is 0.25. So that tells me we have a vertical compression. My h value is 0, so there's nothing that happens here. K is -6, so it goes down 6. My domain will be all real numbers. My range, A is positive, so that means I'm going to go from K to infinity, so -6, infinity. And then I have an asymptote at y equals K, so y equals -6. So we're going to go ahead and fill this out. So in Desmos, I would do 0.25, parentheses 4, close parentheses, exponent x, out of the exponent and do -6. And so looking at it, I guess I can go ahead and share it. Won't really make it because we're going to come right back. Here's what it looks like. Here is my table. It would be nice if I could just copy these values and paste them in there. But those are the points I'm going to go ahead and plot. So actually, there is a way for me to go ahead and do this. Let's see, I want this one, but I want to write on this one. It's not going to let me. That's fine. So actually what I can do is we're going to move you over here so I can see it. So we're going to go ahead and go back to the PowerPoint, fill it in, and we can go ahead and graph everything we need. So I'm just going to go to 2 decimal places here. And we're going to get -5.98, -5.94, -5.75, -5, -2, and 10. We're going to go here. So there is where I'm going to draw my Cartesian plane. So I'm going to draw my asymptote. I'm going to do it we'll do it magenta. We're going to go down to -6. 1, 2, 3, 4, 5, 6. Just drawing really, again, Alex will go ahead and give you the dashed lines as needed. You just have to place it. And let's go ahead and we can do this in green. So we're about here. We're just going to get really close. So I'm not going to be worrying about -2 and -1. -1 is at -5. 2 is at -2. And then 3 is at 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you go ahead and graph it. Again, you plot the points. Alex will go ahead and sketch the graph for you. You don't have to do too much on that. For the last one, it is a UDO. I'm not going to worry too much about the graphing. I do want to go over, though, the information. So here we would have a decay function. My A value is -3. My H value is 0. My K value is 2. My domain is all real numbers. My range, we're going to come back to that. And my asymptote is at y equals 2. The -3 tells me we have a vertical reflection and it is vertically stretched. Even though it is a negative number, the 3 makes it stretched because we're looking at the absolute value of A when we're looking at compression and stretches. On K equals 2, we go up 2 units. Since the A value is negative, we start at -infinity and we finish at our K value, which is 2. So I am only gonna I'm not gonna worry too much about the table. On this one, I do just want to show you what it looks like. So we have -3 parentheses 2/5 close parentheses to the x power plus 2. 0 crosses at -1. So there's a couple things we can decide on it. Such as we know the asymptote is at 2, and I'm just gonna, there we go. Technically it is dashed. And it crosses at 0, -1. Oh, that's the wrong color to pick. Let's go with red. And then it gets really close to 1 is almost at 1. So about here. And it's just gonna get really close. -1 is at 5.5. 1, 2, 3, 4. And it's just gonna grow really fast, so we can't even show most of it. That's what it looks like. I will go ahead and share it in from the from Desmos. So here's what our graph looks like. Very much, mine looks not as nice, obviously. If I wanted to, I can draw my asymptote y equals 2. And I'm gonna go ahead and we're gonna make this a dashed line, and I'm gonna make this at a 1, no, at a 2, 1.5. And I'm gonna zoom in actually so you can see the asymptote, and you can see it's getting close to it, but it's never gonna actually touch it. Like I can keep zooming in. Every time I look like, oh, look, it's touching, I can zoom in more. And you can see there's just that tiny bit of space in there. But yeah. Oh, and there's the table if you wanted to see the table. Pretty much that's it. There is the DOLs online in the book website. You are welcome to go ahead and attempt it. But that is all I have for you today. It's a very short lesson. It was one that was meant for you to be able to do on your own in case of me not being here for testing or you missing class because of testing. It was planned this way. But that is all I have for you, and I will see you guys next time in class. All right, bye.